here I've created this little 5-story building, concrete building. It's got 5 floors. I've put one Supershell on each floor. It basically encompasses the entire floor, one on each floor, like I said. Then I've got these shear walls, one on the left and one on the right. And the thicknesses of the shear wall is about 20 centimeters, and the thicknesses of the slabs are also 20 centimeters. I think that's the unit, yes. And I have loaded it basically to give a uniform vertical load on each of the super shells in the live load case. It's about, I don't know, about 200 kilograms per meter square or something like that. And then I've given it some wind X loads and some wind Y loads. And basically, I haven't gone into the detail. I just put some loads at the top level and some loads from in the X direction at the top level and the Y direction at the top level. And those are in my wind X and wind Y load cases. And now what I will do is I will run this analysis in front of you. So what it will do is it will create the mesh at runtime. Like we discussed, we could have had holes, we could have had line loads, all sorts of things would have been possible. But I just want to show you the results of how we check the results of the super shells. So let's run the analysis in front of you. It says the project is going to be saved. Do you want to continue? I say yes. And now it's meshing the entire structure, and it's a fine mesh. So it takes a few seconds, and then it basically finishes the job. So let's check the deformed shape first. That's what an engineer should do first, just in case there's anything wrong with the model. That'll be the first place which makes that apparent. So if you press that button, we come to this different page, and where we have these options to play around with the deformed shape, and we can rotate the view over here like that as well. And what we see is the live load case. Like I said, we had entered the live load case in which there were vertical loads, wind X and wind Y. So right now we are seeing the live load case, and we can, like I said, turn it around to see from various angles. If we press this animate button over here and say start the animation, we can see how it's going to deform. And while it's deforming, while it's animating, we can also turn it around. One thing I can do is I can change the load case to wind X, and when I do that, I can turn it to the side as well, and I can see how it is deforming. Once again, I can turn it to wind Y, and this time it's the other direction. And like this, I can easily inspect what's happening with the deformed shape. Now let's get back to the structure itself. And over here, you have this contouring option. And if I press this button from here, this submenu appears. And if I go in there, I can set the settings for how the contours will be plotted. So let me do that. So over here, I have the option of plotting either forces and moments on the super shells, or stresses on the super shells, or we also have soil pressures and surface displacements, surface loads, and even areas of steel. So I'm going to start off with the forces and moments. And once if you choose the forces and moments, then you have F11, F22, F12. These, as you know, are the shell internal forces. F max, F min, M1, M2. Let's keep it at M1 because we're going to look at the slabs right now. And over here we can have a customized range for the output as far as the M11 values are concerned. We can choose to create contour lines or draw the mesh, etc. Let's just leave it like that. And after doing the settings, we just basically press this button over there, and it's going to create the contours of the results of M11. And on the right hand side, you see this legend, which tells you what are the minimum ranges of the stresses in whatever units you have over here, and what are the maximum you see on the screen. And this is a very easy way to inspect the results. Now, if we were to choose the wind Y direction, for example, to see the results, and go inside and set it to F22 instead of M11, because we want to now see the internal forces in the shear walls. And this is the wind Y direction. So if I turn on the contouring, we will see that we can see how because of the lateral loads in this direction, the shear wall is getting compressed maximum at the ends, of course, and as it's getting higher and higher as you go towards the bottom story. The same can be seen on the other side. and it's very easy to inspect the results like this. Now, coming back to these results for the vertical loads, these M11 results, what we can also do is we can create what we call strip moment lines. So what I do is I just select this button, and I select 2 points. I can select any 2 points as long as they make a line. And then I can select that line, press enter, double click on that, and I can say show the diagram. And when I do that, immediately the moment diagram along that line is created. So if I were to just say select this one and say show only, if I were to, for example, select this and say show only this one, I can see the moment diagram across that line, and I can place my steel accordingly if reading from the Supershells is a bit more difficult. And similarly, I can create this line in the other direction as well. So I can have this line from this direction, from this point to say this point. And now once again, I can select that line, press enter, double click on the force moment, tell it to show the diagram. And once that happens, I can now see the diagram in the other direction as well. So these strip moment lines can be, like I said, they're lines, they can be in any direction. They're particularly useful if you're doing something round, for example, a circular slab, and you want to place the reinforcement in the radial direction, for instance. But the supershells have been created in whatever coordinate systems which you needed for creating that circular slab. But you want to see the moments along the radial line. So you just basically use this strip moment to create along the radial direction, and you will get to see something like this to see what the moments are along that line. Now, as I had mentioned earlier as well, that if you go to the settings over here, you have these various options of checking stresses or forces or soil pressures, and you also have this option of checking the area of steel. And if you select that, then you have these options of checking the top surface area in the 1-1 direction, bottom surface area required, the area of steel required on the bottom surface. Similarly, along the 2-2 direction for the top surface and the bottom surface. So let's just check for the top surface what our requirements are. So how much area of steel we need for the top surface. And when we do that and we press this button, we see that for the top surface, we basically don't require, so there's 0 over here. This is centimeters squared of area per 100 centimeters. So we basically don't require anything in the middle. We only require the top surface area in this region. And we can check how many centimeters squared are required using the legend over there. Similarly, if we were to go back in and check for the bottom surface, we will get the opposite result, or similar, because then we don't need any bars in this area for the bottom surface, but we basically need it for the bottom. And over here also, if we know how much minimum reinforcement we're going to provide anyways for the slab, so let's say we're going to provide a certain minimum reinforcement, and we know what that number is, so we can put that number over here. And so what it will do is it'll only tell you about the areas where even that minimum is not enough. So if I change the minimum over here in the customized range session, what it will tell us is that your minimum is basically okay everywhere as far as the bottom reinforcement is concerned, but these areas require reinforcement. This is from the range from the minimum to the maximum. The blue areas basically won't require any because you already have the minimum over there. So it's a nice way of checking wherever you want to put some extra reinforcement. And if it is not concrete slabs which you're designing and you're interested in steel plates and their stresses, then in that case you will obviously go to the stresses section and probably be more interested in the von Mises stresses, and you can easily then tell which areas of your structure are being pushed to the limits, and then you can increase the thicknesses of the plates in those areas. Now there's one very handy little feature which I just want to talk about for a few seconds and then move on, and that is if you go to your Supershell tools menu, you have the option of splitting supershells and converting plates to supershells, but there's also this option of converting any surface into a supershell. And this is pretty handy, and at times it can really help you quicken your modeling time. So what you do is you basically just select this, and then you can select any surface on the screen. So let me just select this I-beam flange and this I-beam web and this the back of the flange again, and then this web and this flange and this bottom flange, and for the column as well, this one and this one, and for this plate and for the plate at the back. I'm just doing random selection right now, just to give, and maybe I want to select this plate over here as well, and I right click and I interrupt. And if I go into my visibility settings and I just open my Supershells right now, you can see that Supershells have been created for that area, and I could have continued clicking. And then obviously you have to now go in and do the rest of the modeling. But this will, if you wanted to, for example, somehow model this connection, or it could have been some other instance where you could have used the surfaces to create your supershells. Now each of this is a supershell. You can go in, you can change the density, you can change the thickness, you can use all the features which you talked about for internal lines and internal points, and you can have your points of the bolts, for example. You can have little elements connecting them and stuff like that. But this is just something I wanted to mention, because it is very useful in quickly creating supershell models from something existing which you have on the screen. Now let's talk about viewing the analysis results on the screen. So we can do that in both tabular as well as graphical form. So if I were to select a column, for example, and go over here and say I want to see the joint, the element analysis output tables, we can select any load case which we want from here, and for that column it will tell us about all, because this column is a huge column. It's going from this story all the way 2 stories up, and these stories are pretty tall. So it'll give it from the start segment 1, segment 2, segment 3, all the way down till the end of the section. And you can even ask it to increase the number of points for each segment, and you will see all your 6 major results: your axial force, your shears in the 2 directions, your torsional moments, your moments M22 and M33, etc. If you want, while the table is open, you can switch to another element. If you want, you can select multiple elements, and the entire tables for all those elements will be presented to you in tabular form. What you can also do is to select any element, and then instead of the tabular format, you can do it as an internal force diagram as well. So once again, I've selected the same column and I've chosen the live load case, and I can move my mouse cursor over the column, and I can see the actual values in whatever units which I want. And I can see values for the axial force, the torsional moment, the bending moments, etc., and even the deflections, depending on what load case I choose. If I wanted to see the results for the entire building in one go and not element by element, I could just go to this command over here and say turn on my M33 moments for the entire building, and then I can zoom in and see what their relative values are. If I select a particular element, then the values of that particular element will be shown. If I just don't select anything, then everything will be shown, but that obviously becomes a clutter depending on how complicated your building is. But what you can do is you can go and select any particular element, and then you will see the values of whatever moment diagram or shear force diagram which you are printing on the screen. Now let's say we are in this view, which is a plan view, and I wanted to look at the M33 moments, for example, for the elements which are visible in this view. If I press that, I'm not going to see much because the M33 moments are out of this plane. So what I have the option to do over here is to say project to the current view. Now if I do that, then my M33 moments are projected to this view, even though they're actually in the other direction. But since I'm working in the plan view, this provides a handy tool for me to see which particular beams are being stressed the most and where the moments are the maximum and stuff like that. So this ability to project to the current view is very useful when you're working in plan or sectional views.